All right, so this is the final video for the Prompt B series on how to do the last calculation of calculating the number of cysteine residues per GAPDH protein. So this pretty much just tells you to take your answers from Prompt B3, which we found out in a separate video that we had 105.6. This is actually shouldn't be on there because there was no error associated with that whatsoever. 105.6 nanomoles of sulfhydryl groups that reacted with the DTNB reagent. And to take our answer from B8, which was the prompt immediately before this, on the average number or the average nanomoles of GAPDH in those reactions, which we found out to be in the last video 26.36744 plus or minus 0.2409 8945 nanomoles. And this of course is nanomoles of GAPDH proteins. So in order to do this calculation, we just have to do one final division step in which I'm going to use my error propagation calculator to do this because I don't, I'm not going to do this by hand. Plus also, it's difficult for me to do anything by hand on the computer to show you all how to do this. So I'm just going to have these two values here, and I'm going to do a division step where I'm going to take the nanomoles of the sulfhydryl groups and put that in for this value here. So I'm going to have 105.6 as the sulfhydryl groups. There was no error associated with this. And then I am going to then, for the denominator, the big B, little b values, I'm going to put in my answer for prompt B8, which big B is going to be 26.36744, and the associated error is going to be 0.248945. When I do that, now I'm looking for the division result of these two values. So basically, I'm going to kind of just show you in Microsoft Paint here what this is going to be. Again, I'll just write it out here, 105.6 plus or minus 0 divided by 26. If you wanted to resolve this by hand, good for you. But for the purposes of this, I use the error propagation calculator I'll just round this off here. The numerator here was, for the units, was the nanomoles, close that off there, of sulfhydryl groups, or cysteine residues, basically. And then the units for the denominator here were nanomoles of GAPDH. So when you do this division step for the actual values, after you do error propagation like I showed earlier, and that resulting value was, for the division, 4.0 plus or minus 0.03. 4.00, I'll just use 2 decimal units, plus or minus 0.03. 0.0, is that a 3? 0.04, I have to round up. So the units now, nanomoles, will cancel out, and then basically it's this resulting unit is sulfhydryl groups, SH groups, or cysteines, because that's actually what reacted with the DTNB per GAPDH. Now this is actually pretty cool because these, the only values that you didn't get for yourself were the dye binding assay values, in which pretty much we kind of just looked up a previous TF data and we just gave those to you. But this value is telling you that for every single GAPDH molecule, there are 4 sulfhydryl groups or 4 cysteine residues. And that's actually pretty cool, because if we go ahead and just, you know, open up a kind of like GAPDH sequence for this, you know, I typed in uniprot, and we want to make sure that we're using the same species. If you remember, we used rabbit GAPDH for these experiments. So I think, I forget exactly. I think it's like, yeah, Arctolagus conicus for rabbit. We can pull up the sequence for the rabbit GAPDH that we used from Sigma Aldrich, look up the sequence, which is here. And if you go ahead and we just, you know, take this, copy this, open up a Microsoft Word document so that we don't have to spend, you know, 5 minutes counting this, and we just paste this whole document here, do a simple find for C for cysteines for those residues, we'll go ahead and find all 4 of those in there. It's pretty cool that this technique gives you a very close estimate to the number of cysteine residues per GAPDH. And then also with that calculation, you also have like a little bit of error as well. Now, unfortunately, we couldn't do the C14 iodoacetate route, and also using those values calculate in another way the number of sulfhydryl groups per GAPDH. I think for that one, it's, I forget exactly which trend it is, but I think like the DTNB assay is always just a slight bit more accurate than the C14. But even the C14 is actually, it's you know, it still gets you within that same number. I think like for the C14, that one's like 3.5 plus or minus like 0.1 or something like that. For the cysteine groups per GAPDH. But essentially, you know, this was pretty much the end of that final calculation where you're able to calculate the number of cysteine residues per GAPDH with all of these different values and all of these different conversions.